Good day, my fellow physical scientists. In this video, I'm going to briefly cover some of the key considerations and recommendations that we as a group discussed during our end of year session. And we made some recommendations and some considerations for the 2020-2021 school year pacing calendar. For the most part, the current construct of the pacing guide is excellent and crafted well. Therefore, for those of you out there who have a desire or would like to add more to the discussion for our consideration and recommendations for the pacing guide, please feel free to take the opportunity to post those comments in the CCS Physical Science Google Classroom. Without further ado, let's move forward. The current physical science curriculum is broken down into 12 sequential units. Unit 1 is an intro to physical science. Units 2 through 6 are the chemistry phase of physical science, and then units 7 through 12 are the physics portion of the physical science curriculum. We're going to address each unit, starting with unit 1 all the way through unit 12, and we're going to look at what is already in place, and then we're going to look at the changes and recommendations that were made. As you look at the slides, you will see the first slide will represent what is already established in place and what is already currently accepted. And then the next slide, they will generally have the changes in red. Those are the considerations and recommendations or areas of focus that we as a group discussed at the end of year session. Unit 1 is the introduction to physical science. This is a general overview of primarily the concepts and tasks that will be covered throughout the chemistry phase of the instruction. There are, however, a few concepts related to heat and energy, which is covered in the physics phase, specifically in Unit 10, and we as a group determined that we should be a little flexible during this time. So instead of 11 days of instruction, we're going to have 10 days of instruction, which includes the assessment as well. There are considerable class changes, students dropping and adding during this time. Nevertheless, the bullets in blue are a list of topics for emphasis, by which you as a professional are by no means limited to. The list takes into consideration the tasks and concepts that are generally pervasive throughout the school year. The math concepts that challenge us throughout the school year, metric conversions, SI units, and periodic table trends. Also note, Unit 1 is the only time as well that you will directly discuss the phases and states of matter, to include water deposition, sublimation, heat of fusion, and heat of vaporization. Unit 2 is when the meat and potatoes of the chemistry phase begins. Recommend focusing efforts on fundamentals that will be necessary for success throughout units 2 through 6, and key concepts that will be revisited in those subsequent units of instruction as well. Of note, this would be, if you have time, a good time to introduce oxidation numbers as getting learners to grasp the principles associated with oxidation numbers and the octet rule has shown to be a challenge. By the time we get to Unit 3, you should have your full complement of students. It is also, as agreed upon by the group, that it is the first unit where the fundamentals have to start building into more complex principles. This block of instruction includes the 3 types of bonding, the octet rule, Lewis dot structures, polarity, diatomic molecules, polyatomic ions, and nomenclature. Recommend using the interactive study guides and homework to further emphasize and stress certain points that students may find challenging. Unit 4 is everyone's favorite, balancing equations. Most of us have not managed to get through introducing the 5 types of chemical reactions and balancing equations, whereby the learners are reasonably proficient by the end of this block of instruction. Therefore, the recommendation is to cover the easy stuff up front and introduce the types of equations, the types of chemical reactions up front, and then use those last 2 days before the summative on balancing equations. And that includes differentiating with homework, practical exercises, focusing efforts on learners that are finding the notions of balancing equations challenging, while also pushing the more proficient students using the balancing equations handbook. There were no substantive changes to Unit 5. The only recommendations were to spend at least a day on how to manipulate, understand solubility curves. Also, as with Units 2, 3, and 4, take the opportunity, perhaps during warm-ups or to close out summary in class, to spiral back on metric conversions, SI units, and math principles. Remember, we want to ensure that those math principles have been ingrained before we get to the physics phase. If we are successful in that, then by the time we get to the physics phase, students will have a grasp and a complete understanding of how to isolate a variable and manipulate the data as necessary to solve for that variable. Generally, if you had fun balancing equations, then you are really gonna love half-life calculations. There is a lot of math covered in Unit 6. Therefore, the homework and studying should be concentrated primarily on the vocabulary words or terms of reference, and the bulk of the heavy lifting in class focused on alpha and beta decay calculations, half-life calculations, and understanding fission and fusion. Now we have reached the end of the chemistry phase. Now, during the chemistry phase, what we've also been doing is preparing ourselves with respect to the math concepts to move into the physics phase, whereby there are variables. You have to isolate those variables and solve for them. So the recommendation was during Units 2 through 6, we would subsequently spiral back during those units, primarily using density equals mass over volume and reiterating those principles associated with demand, as well as metric unit conversions and an emphasis on SI units. So now we're going to move into the physics phase of the recommendations and considerations, and it's going to go a lot faster. There were not any big changes with respect to the physics phase because the math concepts and the math tasks have been usually our biggest hurdle. So let's move forward to the physics phase. There were no significant and substantive changes to Unit 7. However, there was a recommendation on spending at least one day on virtual labs related to motion. Also taking into consideration of note, there have been and still going on, there are some changes to the Flash players associated with Google Chrome. Some of those virtual labs that we have been using in the past and have been posted in our Google Classroom may have been affected by that. Nevertheless, as you go out and search for virtual labs for the physics phase, if you find some that are very well done, work very well, please, again, post them so that we could share them in our Google Classroom with our fellow physical scientists. We recommended that Unit 8 have at least one more day of instruction to ensure that students not only grasp the mathematical concepts, but You will also be introducing Newton's 3 laws of motion and a new set of equations. Force equals mass times acceleration, weight, and momentum. Students at this juncture will also figure out that the SI units are key to understanding what they are working with, and that those SI units will change. For example, some SI units will require that mass be calculated in kilograms now instead of grams. So take this opportunity in Unit 8 to not only continue to do some motion and speed labs, but to emphasize SI units and how those SI units will be changing from this point forward, as well as introducing more metric conversions into the curriculum. There were no changes to days of instruction and methodology for Unit 9. However, Unit 9 will be the first time your math narrative changes. Up to this point, we have been having students get accustomed to 3 variable problems, whereby 2 variables are given and 1 is solved for. Actual and mechanical advantage and efficiency are different in that respect. The same basic math principles are there. Nonetheless, it may be different for some of your students. Also, take the opportunity during Unit 9 to introduce 2-step math operations, particularly for those students that are more proficient. For example, in order to find power, work and time has to be given. But consider giving the students a problem where force, distance, and time are the givens. Also, some of the metric units may require conversion. To solve the equation, power equals work divided by time. However, have students determine work first by multiplying force and distance, then dividing it by time. Once we get to Unit 10, you will be reviewing some terms of reference: kinetic energy, potential energy, conduction, convection, and radiation. Those were introduced to the students in Unit 1. Now we move forward in Unit 10, it will be a review of those concepts. We recommend 1 more day added for instruction so that we could work on the new math principles that have been introduced in Unit 10. The recommendation for Unit 11 was to add 1 more day of instruction so that we can thoroughly get through the behavior of waves, the electromagnetic spectrum, and the Doppler effect. We've all agreed as a group that most of us have not been very successful in getting through Unit 12 in 4 days. The recommendation is to break the unit into 2 blocks: electricity and magnetism. So those are the considerations that we've made as a recommendation for the pacing guide for the 2020-2021 school year. For those of you who have not joined our CCS Physical Science Google Classroom, I'm going to provide the code and show you how to navigate to the Drive folder where there are a host of resources available for you. Feel free to use them at will. Enjoy your upcoming 2020-2021 school year. And remember, I love science, and you do too.